Hello everyone, this is Mr. Wilhelm and we're talking about section 1.2. Today we're going to go over a variety of things, first being more specific in the parts of a degree, also recognizing congruent angles and segments within a diagram based on tick marks. Talk about the hands on a clock and finding the angle between those hands, and then finding restrictions on angles and variables. First off, breaking down a degree, we can get more specific than degrees. The first thing is minutes, and 1 degree is equivalent to 60 minutes. And we could also break down a minute, with 1 minute being equivalent to 60 seconds. This allows us to then break down 90 degrees into different parts. We could break down 90 degrees by taking away a degree, which is equivalent to 60 minutes. We could also get even more specific by breaking down the 60 minutes and making it 59 minutes, but that minute is still there as 60 seconds. The same thing could be done with 180 degrees. We have 179 degrees and 60 minutes. That still adds to the 180. Or break it down further by taking away a minute and adding the 60 seconds. We can convert between degrees and minutes, or just as degrees. In this next problem, we have 52 2/5 degrees. That's 52. Excuse me. We have 52 degrees and 2/5 out of a possible 60, and that allows us to reduce to 52 degrees and 24 minutes. We can then keep a problem in just degrees, because in this problem we have 74 and 35 out of a possible 60 degrees, which reduces to 74 and 7/12 degrees. In this next problem, we are given the fact that the entire angle is a right angle, and then we are given angle CDB being 59 degrees, 24 minutes, and 47 seconds. So to find the remainder, we need to subtract the angle that we are given from the right angle, which is 90 degrees. And this goes back to the previous slide why we were talking about needing to break down the 90 degrees. This does not allow us to subtract because we do not have the minutes or the seconds. So if we go back to the previous page, let's just say that 90 degrees is equivalent to the 89, 59, and 60, we can break it down and allow us to subtract, changing 89 degrees, 59 minutes, and 60 seconds. When we subtract then, we get a final answer of 30 degrees, 35 minutes, and 13 seconds. The same thing can be done with the straight angle. We are given that angle FHE right there, and we see in the diagram that it is a straight angle, so we can subtract what we are given from 180. Similar as the last problem, this does not allow us to do the problem. Now there are two ways that we can do the problem. We can convert the 180 to 179, 59, and 60, or we can simplify the 56, 75, and 87. If we were to break down the 180 to 179, 59, and 60, as we talked about on the last page, we see that we still cannot do the problem. So we need to essentially borrow again. So if we take away a minute and we go down to 58 minutes, that allows us to add 60 seconds to the problem. Now we have enough seconds to subtract, but we still do not have enough minutes, so we need to borrow some more minutes. So when we borrow from the degrees, we're down to 178 degrees, and we add 60 minutes. Now we're able to do our subtracting. And that gives us a total of 122 degrees, 43 minutes, and 33 seconds. You could also do it by simplifying the 56 degrees, 75 minutes, and 87 seconds. When you take away 60 seconds, you're down to 27, and that gives you 76 minutes. And then you could also simplify the minutes 60 to 16 minutes, and you add the degree, and now you would be able to subtract that from the original 179, 59, and 60. In this next example, we're talking about recognizing congruent angles and writing a congruency statement based on the diagram. The first pair of angles that we can see are congruent based on the tick marks are those two angles. And as a congruency statement, it's angle MPA and congruent to angle CFG. The other pair of angles that we can recognize are congruent based on the tick marks, right there in red. A couple different ways you can write that. It's angle FGT down here, but you can also write FGA. If you were to go all the way across, you can use either the T or the A. And then the other angle what's congruent to is angle AMP. And again, you can do the P or the T. Recognizing pairs of congruent segments with the tick marks, we have segments on each side, right there in green, which is segment MA, congruent to segment HT. We also have another pair of congruent segments right here in blue, which is written as segment MP congruent to segment PT. We can also write other names for angle 2 that still reference this angle. These two rays are the rays that form that angle. So we could write it as using the letters angle M, HP, and then as stated before in the last problem, you can use past P, you can write the letter A, so it's angle M, H, A. It's not congruent, these are just other names. And the different angles that are with the vertex of M, we have a couple different angles. We have this first angle right here, which is angle AMP or AMT. We also have an angle up top here, which is angle HMP or HMT, and then we have the entire angle formed at that vertex, which is angle AMH, and we could use the letters N or C in place of H as well. The next couple examples, we're talking about finding the measure of angles formed by the hands on the clock. First off, it's important to know that in a circle we have a total of 360 degrees, and the clock is divided into 12 regions by the 12 numbers, which tell us that each region has 30 degrees in it. Then we need to accurately draw 830. The first thing that we need to do is find out the whole 30-degree sections. I see that there are two whole 30-degree sections, which gives us 60 degrees. And then we need to talk about the partial section right here. The hour hand is past the 8 o'clock by the 30 minutes out of a possible 60 minutes, which tells us that it is halfway between the 8 and the 9. So we need to add half of the 30-degree region, which gives us a total angle of 75 degrees. The next one we're talking about is 4:45. First off, again, find out the 30-degree sections, which in this one, I see there are 4, so I have 120 degrees to start. And then I need to add this partial region. And this time it's not how far past 4 o'clock it is, it's how far until 5 o'clock. And I have 15 minutes to go to get to 5 o'clock. 15 out of a possible 60 minutes, which reduces to a fourth. So when I add those together, I get that the angle is 127.5 degrees or 127 degrees in 30 minutes, depending on how we want that one written. The next two examples are a little different because we have to worry about the minute hand as well. When we accurately draw 142, that is at 140, we have 141 and 142, and then an hour hand. Again, first of all, find out how many 30-degree sections there are. So we have 120 degrees. And then we need to do the hour hand the way we have. It's past 1 o'clock. How far past 1 o'clock? It's 42 minutes past 1 o'clock. But then we also need to add the minute hand. And this minute hand is at 42. It needs to go to 43, 44, 45. This minute hand is, the minute hand travel is broken up into fifths. 1, 2, 3, 4, 5. It needs to go 3/5 of the way. So we have 3/5 of the possible 30 degrees. So when we add all those up, we find out that the angle at 142 is 159 degrees. Once you pause the video and find the angle at 338. At 338, we find that there are the 330-degree sections, which gives us 90. The hour hand has 22 minutes to go until it gets to the 4 o'clock. So we have 22 over 60. And then the minutes hand has traveled the 36, 37, 38, so 3/5 of the way, which gives us a total angle of 119 degrees. The last thing we're going to talk about in this section is restrictions. And if I were to tell you that angle B is obtuse, that tells you that you know that the angle must be greater than 90, but also must be less than 180. You don't know what the angle is, but you know it must be between 90 and 180 degrees. That allows you to also find restrictions on a variable. In this case, we have the angle is acute, so we know that the angle must be between 0 and 90 degrees. And then we can substitute in for angle G what we have for angle G as 2x plus 20. And now we can find the restrictions on the variable in this particular problem. So when we solve the inequality, subtracting the 20 to both sides, all sides, and then we divide everything by 2, we find out that the variable x, in order for angle G to be acute, must be between -10 and 35. And this concludes the notes for section 1.2.